Okay, so here's our final example for sections 5.1, 5.2. We're just looking at shear stress due to torsion. And remember, we have shear stress equals rho T times rho over J. And that's along the radial length. If we want the maximum, it's going to be the torque in that cross section, C, which is the radius, divided by J. So C is the radius, and remember it varies linearly as we move away from the radius. If we have a torque applied in that direction, then we have this nice linear distribution of both our strain and our shear stress. So we have a solid 30 millimeter shaft. It's used to transmit torques applied to the gears. Determine the absolute maximum shear stress in the shaft. So I have a diameter. So I know that my radius is 15 millimeters, which is 0.015 meters. And we want to just determine the absolute maximum shear stress. It's solid, so our J, our polar moment of inertia, is pi over 2 times 0.015 meters to the fourth. And then we're going to be using shear stress equals T C over J. And we recognize that that is my radius. So let's start with free body diagrams. So I can start from either end. I'm just going to start from the front, and I'm going to either look at all of that or look at this. And that's a lot less work. So we're going to start with, we have 400 Newton meters in this direction, and we're going to assume positive from B to D. Because remember, if I'm looking here, positive. If I'm looking back there, into the paper is positive. And then we're going to sum those torques. This is the confusing part. Now we're just going to use our hand as we go back. If it comes this way, it's positive. If it goes backwards, it's negative. So I have 400 Newton meters minus torque BD equals 0. So the torque in BD has to also equal 400 Newton meters, which makes sense. They've got to be twisting equal and opposite, equal and opposite. So if you're positive on one, you're positive on the other. And now we're going to cut between C and D. So let's do our little free body diagram. So we have 400 Newton meters. And then I am taking out. And again, we're going to assume that that torque from D to C is positive. And then we can set up our equilibrium. We're going to sum our torques. It's not a force this time, is it? We're summing torques. We're going to be coming towards us as positive. So I have 400 Newton meters minus 200 minus torque DC equals 0. Take that over. So the torque DC is 200 Newton meters, and that's positive. So now we need to come back here, and we can go all the way back, or we could draw towards us because that would be the shorter little piece, but let's just continue the way we've been doing this. And here's our free body diagram. And I have 400 coming at me. I mean, I know it should end with 300, right? If I'm just looking at this part of the segment, it's got to be 300. And it's got to be 300. If we look at that's coming, this internal is going to be going towards it like this, which is negative. So I'm expecting a negative 300 for my torque. But anyways, let's just go forwards. So we have 200 Newton meters, and we have 500 Newton meters. And then I'm going to assume positive torque from C to A. And I'm going to sum those torques. That's going to be my positive reference. So I have 400 minus 200 minus 500 minus torque CA equals 0. So torque CA equals, take that over, 700 negative. So we get negative 300 Newton meters, which how could I check? Well, I could check that by coming back from the back, and I have 300 Newton meters. I can visually see that internal has to be going in that direction. And when I'm looking at that, that's going to be by right hand. Here's the butt of my hand going towards that end, coming towards me is positive. So I can see very clearly torque CA is indeed negative 300 Newton meters. So now we need to draw our torque diagram. So I'm going to come across like so, and I have torque Newton meters. And when I'm coming over here, so we have 1, 2 gears in the middle, so I have a negative 300. So I can draw this across. It doesn't change. It's not variable. Negative 300. And then I have, so that was torque CA, torque DC, torque BD. Okay. So torque from D to C was positive 200. Okay. And then torque from B to D was positive 400. So what segment has the largest torque? Because it's all the same diameter. It's all the same diameter, so I don't have to worry about checking several different places. I can see that right here that my maximum shear stress is at 400 Newton meters. Or not my shear stress, but my maximum torque. My maximum torque is at 400 Newton meters. So my maximum shear stress is going to be 400 Newton meters times 0.015 meters, that's my radius, divided by pi over 2 times 0.015 meters to the fourth, and let's multiply that out, so I get 400, 0.015 times, pi is a number, 2 divided by 0.015, enter to the fourth, times, and divided by. So 1, 2, 3, 4, 5, 6. Let's do that again. 1, 2, 3, 4, 5, 6. So my maximum shear stress is 75.45, 1, 2, 3 kilo, 1, 2, 3 mega pascals. There we have it. That's the one we would need to make sure was less than. Remember, we always need to make sure that what we get, so we would need to make sure that that shear stress of 74.45 megapascals was less than the yield. Otherwise, we would have some issues. So we'll get into that later when we get into more torsion.